This will be for the Khan Academy exercise, continuity at a point, graphical. All right, just some notes before we begin. If both one-sided limits exist, they must be equal in order for the two-sided limit to exist. Continuous means that you can draw the graph without lifting your pencil. If there is a break in the graph, it is not continuous at that point. In order for a function to be defined at a point, the point must exist. All right, so here we have the function f graphed, and select all the statements about f at x equals 4. So that is right here at x equals 4. Both answer A, choose all answers that apply. Answer A, both one-sided limits exist. This is approaching from the positive side. This is approaching from the negative side. So let's see, at x equals 4, you can approach this limit from either side, and the limit exists right here at y equals 1, okay? If you approach it from the left, or if you approach it from the right, it approaches this point right here, which is y equals 1. So answer A is true. Answer B, the two-sided limit exists at x approaches 4. Okay, so we said if the one-sided limits are equal, then the two-sided limit definitely exists. Like we said, you approach it from the left, approach it from the right, it approaches the same point, y equals 1. So the two-sided limit also exists. F is defined at x equals 4. Well, is there a point at x equals 4? Yes, there is. It happens to be right here, okay? Even though there's a hole in the graph here, there's still a point at x equals 4, and that point is right there. So that is true. Is the graph continuous at x equals 4? Can you draw this without lifting your pencil? No, you cannot. There's a hole in the graph right here, and it jumps down to this point here. So right here, it is not continuous because there's a break or a hole in the graph. So D is not true. A, B, and C, all true. All right, here's our graph. All right, select all statements about f at x equals negative 2. All right, so x equals negative 2 is this right here. And it's all the same type of questions. Answer A, the one-sided limits exist at negative 2 from the positive and the negative side. Well, yes, if you approach it from this side, the left, the limit exists at y equals 4. If you approach the graph from this side or approach from the right, the limit exists at y equals negative 3. So both one-sided limits exist. Does the two-sided limit exist at negative 2? Well, are they equal? No, they are not. The one-sided limit is at 4. The other one-sided limit is at negative 3. So the two-sided limit does not exist. So no answer B. Is it defined at x equals negative 2? Well, does the point exist at x equals negative 2? No, there's a hole in the graph here. There's a hole in the graph here. There's no point for x equals negative 2. So that's no good. Is it continuous at x equals negative 2? Can you draw this without lifting your pencil? No, you cannot. Okay, there's clearly a break in the graph. So only answer A, the one-sided limits. All right, so here we're looking at x equals 0. Same answers, choices as always. At x equals 0, which is right here at x equals 0, do the one-sided limits exist? Well, you can approach from the left, you can approach from the right. They both approach y equals 1. So if they both approach the same number from both sides at x equals 0, then the two-sided limit exists. Is it defined at x equals 0? Does the point exist? No, it does not. It's open. Okay, there's a hole in the graph at x equals 0. It is not defined, so no C. Is it continuous? Can you draw this without lifting your pencil? Nope, there's a hole in the graph here. There's a break in the graph. So that's no good, just A and B.